Welcome. Yes, in today's class, our subject for today is chemistry, and our topic for today is radioactivity. And when we are talking about radioactivity, we are referring to a spontaneous disintegration of an unstable atomic nucleus to, to obtain a stable nucleus. So now, this radioactivity, given this question, to complete the following reaction. This is sodium. The number here on top is called atomic mass. The one down here is called atomic number. Here is atomic mass. Here is atomic number. Here is atomic. Here is helium. The same thing here. The same thing. The same thing here. Atomic mass, atomic number, magnesium. In this question, we are asked to complete this place. Here is unknown. So now, I can assume that place will be x. Let me just say, let this place be x because I'm looking for x. I'm looking for x. So now the same thing here. This one is atomic mass. This is atomic number. This element is called palladium. This element is called palladium. And then here, this place is still unknown. So I can assume here to be x. That means we are looking for this x. We are looking for this x. I did earlier that radioactivity is a spontaneous disintegration or decay of an unstable atomic nucleus to obtain a stable nucleus by the release of energy. So now, if you look at this reaction, these reactions are not stable because of the presence of this X. The same thing applicable. It is not stable because of the presence of X. So now, for this reaction to be stable, you must undergo spontaneous disintegration, and that means we must complete it. You must complete this X. You must complete this X, and the same thing applicable. You must also complete this X. So I assume it will be X. So now we know that we have types of radioactivity. We have alpha decay, beta decay, gamma decay. We also have others like positron. But in today's class, we are dealing with only two types for today. Today is here is one. This one. Looking at this one, I told you earlier, for you to identify which one is alpha particle, you must know their properties. When you know their properties, you know you can identify them in terms of reactions. So now, in the presence of this helium nucleus, so now this one is telling me that this is alpha particle. This one here, the same thing, because this one I don't know this one because when I find my X, that's when I will know this one. And this one here, because of these electrons, minus one electrons, is telling me that this one is beta minus particle. So now, let's take the reaction solution. So now, for this phase one, for you to get this X, what we do is that we take a simple calculation. So as we can get our atomic mass and also our atomic number. So now, for this one, for atomic mass, this plus means it takes everything. This plus here undergoes all of them, both atomic mass and atomic number. So that means solution 1. So one says 2311 Na plus 4 helium to give me 2612. This is magnesium plus X. I'm looking for this X. So now what I will do is that for atomic mass, I have 23. That will be 23 plus I have 4. This sign, that is equality sign, is representing equality sign. So equals to 26 plus, I don't know this X. I'm making that assuming that is the place, so I don't know this one. I'm looking for X. So from here, I can get my X by transferring this guy to B. So if I transfer this guy, I will have, if I say 23 plus 4, that will give me 27. Then I transfer this one, that will be minus 26 equals to X. So my people, 27 minus 26 That means our x equals to what? 1. Our x is 1. At atomic mass level, x is 1. So let's look at atomic number level. Let's look at atomic number level. So now, for the atomic number level, which is this atomic number level. So atomic number. Let's look at for atomic number. So now, at the atomic number, we are having 11, 2, 12. So this is 11 plus 2 equals to what? 12 plus x. Because our aim is that we are looking for x. So now, if looking at this, if I say 11 plus 2, that will give me 18. Then if I transfer this one, that will be negative. So here will be what? 18. Transfer 12, that will be minus 12 equals to what? X. So now from here, if I say 18 minus 12, it's giving me 1. That means our x equals to 1. At atomic number level, x equals to 1. The same thing applicable to atomic mass. X is also equals to 1. So now, let's substitute x equals to 1 and x equals to 1 on this reaction. Let's see whether the reaction will be complete or stable. So now, we are taking, let me take the reaction. We have 23 Na, this is 11, plus this is 4, 2, this is even to give me 26 magnesium 12 plus x. Remember, our x at the atomic mass level, that is it. X is 1. X is 1. So now, at the atomic number, x is also 1. So I'll put 1 on top, also 1 down. So it will be 1, 1. So now, if you look at this is 23 plus 4. That will give us 27. So now, if I say 26 plus 1 is what? Still 27. So if you look at this side is balanced, this side is also balanced. 11 plus 2, that will give us 18. 1 plus 1, 12 plus 1 is 18. So now, the reaction is complete. At this point now, the reaction is complete because here is balanced. The downside is also balanced, the upper side is balanced, the upper side is also balanced. So at this point now, this is where we call, this is where that spontaneous disintegration comes in. That decay to make, which undergo decay that to make this reaction stable. When you undergo this integration, you will notice that the two sides will be stable. That means both the two sides will have equal numbers. So now, if you look at this x, you are having 1, 1. If you can flash your mind back to chemistry of hydrogen. Yes, chemistry of hydrogen, which tells us that we know that chemistry hydrogen is the lightest element known. And under that hydrogen, we have 3 isotopes of hydrogen. So now, under that 3 isotopes, we have number 1 isotopes. We have number 1 isotopes of hydrogen. You can recall isotopes of hydrogen. So now, isotopes of hydrogen. Number 1, we have protein, which is given as 1, 1p. We have protein, which is given as 1, 1p. So now, if you look at, we also have deuterium. We also have tritium. Deuterium, that one is given as 2, 1p. This is heavy hydrogen. This one is heavy hydrogen. Then we also have tritium. Right, that one is given as 3, 1p. You have to remember that atomic mass varies, but atomic number does not change. Atomic number does not vary, but atomic mass varies. So now, if under these 3 isotopes, if you look at this x, the one that represents this x is this man. This guy here represents. So now, in that place of x, I can quickly replace this x now with p. So with this, That is the aim of that reaction for this particular one. For this particular one. And then this reaction is called is under alpha particle. This is alpha particle. Alpha. Alpha particle. Because of the presence of helium, it's called alpha particle. So now people, let's take the second one. The second one says 106. Let's take the second one. The second one says 106, 106, 46 ED plus X will give me 109 AG. That's silver 47 plus 11 P. So now, my people, I'm looking for this X. I don't know this X. So what I'll also carry out the simple calculation as I did for the phase 1. So now for you to do that, follow the same method by saying atomic mass. Atomic mass. Yeah, I'm having 106 plus X. I don't know this X. To give me 109 plus 1. 109 plus 1 will give me 110 equals to X 106. I'm looking for X. I'm quickly transfer this guy to the other side. So in this case now, my X is giving me 110 minus 106. So therefore, my X equals to 4. That means at the atomic mass, X is 4. Let me carry out for the atomic numbers level. Let's see what we have. Atomic number. Atomic number. At the atomic number level, we have 46, 47, and 1. So that means 46 plus X equals to what? 47 plus 1. So my people, if I say 47 plus 1, I'm having it to be 48. This is equal, this is X, this is 46. So from here, I will quickly transfer this guy to the other side. If I transfer 46 to the other side, that will be negative. So that means our X equals to 48 minus what? 46. Therefore, our X equals to what? 2. Our X equals to 2. So my people, and it's telling us that at the atomic mass level, our X is what? 4. While at the atomic mass, our X is 4. So now, at atomic number, our X is 2. So now, that means I can say here is what? 4. Because I calculate for you. And then for this one now, here is 2. So now, if you go to the periodic table, if you look at element that gives atomic mass to be 4, atomic number to be 4, we call that element helium. That's it. So therefore, I can quickly replace here. This does not to be He, helium. For you to know whether the reaction is spontaneous or whether it's stable, check, add the masses, also add the atomic numbers. So if you look at this mass, if I say 106 plus 4, I'm having 110. 109 plus 1 is 110. 46 plus 2, my people, is 48. 47 plus 1 is 48. So at this point, the reaction is completely stable. That's the end of the second one. And let's take this one. This last one, number 10. Let's take number 10. And this one here, this one is called alpha particle. This one is called alpha particle. This second reaction is also called this also alpha particle because of the presence of helium, because that's the number 1 property of the alpha particle. So let's say this is the third one. The third one says, the third one is we're having 64 copper 29. 64, 29 copper to give me 0 minus 1 electrons plus X. My people, I'm looking for X. Our aim is to obtain this X. So now, For you to obtain this x, I told you earlier, undergo the simple calculation. Follow the simple calculation, you get your x. So now let's see atomic mass. Let's look at for atomic mass level. Let's look at what we have. So atomic mass having 64 equals to 0 plus x. 64 equals to 0 plus x. 64 equals to 0 plus x. 0 plus x is x. So here we cancel out. So now my x equals to what? 64. At the atomic mass, I'm having x equals to 64. So now let's look at for the atomic number. So at atomic number, I'm having 29 equals to minus 1 plus what? X. So what I will do, I'll quickly transfer this guy to here. Once I transfer this guy here, I'll have my x. So now I'm having 29 plus 1. When a negative 1 crossover is positive x. So 29 plus 1 is giving me 30. So now 30 equals to what? X. That means at the atomic number level, x is 30. Atomic mass, x is 64. So now if you want to know the main difference between alpha particle and beta particle, I told you earlier, because of this man, electrons, minus 1 electrons, it means here is negative beta particle minus beta particle. So now, if you look at here, at the atomic mass, in beta particle, it remains the same. The mass is fixed. The mass remains constant. But at the atomic number does what? Varies. Then come to this man, come to alpha particle. Both the atomic number and the atomic mass is varies. So, but for this one, atomic number varies. For beta minus, note for beta minus, atomic number does what? Varies. So now, that means at this point now, for me to complete it, at this point, I'm having 64. Here is 64. Then here is 30. Here is 64. Here is 30. This element, because we are having 64, it therefore means that copper, atomic mass of copper, atomic number of copper could be 30 or 21. And you can still represent here as copper, or you can still leave as your x. And at this point now, if you look at the reaction is completely stable, because here is 64. Then 0 plus 64 is 64. Here is 29. Minus 1 plus 30 is 29. So my people, that is how to differentiate between beta minus and alpha particle. So in our next class, we will look at other types of radioactivity. That is when I'm talking about other types, I'm talking about positron, electron capture, gamma rays, and those are the 3 types we are going to look at in our next class. So stay informed so that you always be active, so that in our next class we look at other and also look at more of radioactivity. So subscribe, share it to other people as you are watching. Thank you.